Hi, welcome to this Open Security Summit 2021 in April. This is going to cover a very interesting topic about a project that I've also been quite closely involved, called Compliant Kubernetes, and we got Cristian and Jakub here, and they're going to walk us through it, and they're going to give a really cool case study. So, over to you.
Thank you for the introduction, Dennis. So hello, everyone. My name is Cristian Klein. I'm a senior cloud architect at Elasticys, and I'm also a researcher at University, both located in Sweden. And together with my colleague, Jakub Krzywda, we worked on a very interesting case study at Compliant Kubernetes as part of Glasswall. So today I'm going to tell you a little bit about the context, just very briefly about content disarm and reconstruction, what it is, what problem it solves. What are the challenges that we were subjected to? So this basically refers to security observability on any cloud. And then finally, we'll show you what solution we have developed as part of this case study, which is based on compliant Kubernetes. So let me start by telling you a little bit about content disarm and reconstruction. The idea is that more people are working from home, which means that they're not any more subject to the traditional protection that they were used to in the corporate walls. So they no longer have access to, they're no longer passing through corporate firewalls, their laptops are suddenly at home, they're having internet access through their traditional ISP. They might even be sharing equipment between their private and their work life. So the attack radius and the extra vulnerability, the extra risk that they're exposing themselves due to this is, of course, a lot larger. And files are a very common and very easy attack vector because, let's be very honest, you have phishing, you have malware, you have social engineering. It's so easy to trick people into opening that magic PDF file with an invoice that you weren't expecting. I actually got that just last week. And you're exposing yourself to risk. There might be some malware, there might be some vulnerability in that particular PDF. And then when you open it, you are potentially exposing yourself to an attack. So what CDR does, content disarm and reconstruction, it parses a PDF, a potentially malicious one. It looks for all of the blocks inside the PDF. And then if there are any problematic ones, then it basically just either replaces them with some visually identical ones, or it maybe even disables them completely. And the aim is at the end to create a visually identical PDF file. So the user should not really notice that the PDF was disarmed. It just kind of should feel the same way. So typical things that you would like to disarm is, for example, URLs in text, which they might look like they're sending you to one link, like say www.google.com, which looks harmless. But then if you're clicking on it, it might send you to www.attackerswebsite.com, again, exposes you to a certain risk. So architecturally speaking, CDR looks pretty much as follows. We have something like an HTTPS or an SMTP proxy, which is used to intercept certain content. Commonly, this is done via a protocol called ICAP, Internet Content Adaptation Protocol. And that is being sent to ICAP service, which is the start of the Glasswall application. And this one, first of all, downloads the file that needs to be disarmed in an object storage, and then sends a request for this to be disarmed in a message queue. And then afterwards, there is a certain process that basically spawns one CDR containers, one content disarm and reconstruct container per file. This is in order to ensure that there's as little as possible interference between the various files that are being reconstructed. And of course, this is all built on top of Kubernetes. Speaking of which, I might be using the words containers and pods interchangeably because in this particular application, one container corresponds to one pod. And at any rate, it is based on Kubernetes, which we all know is dealing with pods really. And the reason why it's based on Kubernetes is twofold. First of all, it allows conveniently the CDR containers to be launched and scheduled on nodes where there is capacity. If you're not doing this properly and bringing your own solution, you might end up with, for example, running out of capacity issues, such as having the out of memory killer or the system just working slowly because it tries to somehow figure out how to allocate more capacity than there is. And Kubernetes, at the very least, it will keep your pod in pending state if you're doing things right. And the second benefit that Kubernetes brings is that it's a really good platform to build cloud agnosticity on. So you can see it almost like an insurance. in order to ensure that this particular CDR application can be run on multiple machines on any cloud possible. So this looks pretty great. I mean, we moved this file risk away from the user and deep into the CDR containers, which I have marked in these particular slides in red. However, of course, we don't want to stop here. The thing is that since now the CDR code becomes the new target for vulnerabilities, it needs to be resilient to zero-day vulnerabilities. It needs to be resilient to denial of service attacks. So somebody sending an oversized PDF or a zip bomb or whatnot in order to try to make the code fail. It needs to be resilient to resource exhaustion. So you don't want to, for example, send huge, you're sending a PDF specially crafted, and then for some reason this CDR code is just failing because of resource exhaustion and is disabling the whole CDR application. You don't want that. And of course, it needs to be scalable and fast so that the users basically don't notice that they have this extra protection while at the same time still benefiting of it. So the challenges that we're facing on, first of all, we need to make sure that this truly runs on any cloud. And throughout these projects, we made it run on top of VMware vSphere, on top of AWS. At some point, we will ask to also plan for potentially running it off top of Azure, but that did not happen. But anyway, we're ready to do it. And of course, we also support configurations such as bring your own virtual machines or bring your metal, because you never know exactly what the next customer will be asking to run this application on. And now, as I said, Kubernetes offers you very good insurance for making sure that you are agnostic to clouds and you can potentially run your application on any clouds. However, the devil is still in the details. How exactly do you configure Kubernetes for each cloud provider is quite a challenging issue. There is a lack of skill set in the market for this. Most of the people are just used to going to some kind of managed Kubernetes service, such as the Amazon EKS or the Azure AKS. But that, of course, makes it very easy to deploy Kubernetes on one cloud provider. But there's a whole different challenge to make it run on any cloud provider. Then the second challenge was really security. So Kubernetes is not secure by default. This has been the subject of quite a lot of tension in the community. The reason is that they do want to preserve this wow effect. It just runs by default instead of having to, teach developers so much more before they can just get started on top of Kubernetes. I'm personally expecting that it will become more and more secure by default, but finding the right balance between this wow it works effect and wow it's secure by default effect is a difficult trade-off as of today. However, Kubernetes does offer some really good facilities for security hardening. So it offered pod security policies. I said this in the past because it was recently, I think last week, announced that these will be deprecated in Kubernetes version 1.21. And then in Kubernetes version 1.25, they will be completely eliminated. Instead, this function is going to be taken by third-party or external policy engines, such as Gatekeeper and with Open Policy Agent. Kubernetes also offers a rich language role-based access control. However, of course, you need to ask yourself, do you need to auto-mount the service token to begin with? Because it's maybe better to not give your pod any access to Kubernetes API instead of giving it access and then restricting it by role-based access control. And then one of my favorite tools to enforce the strong security parameter, network policies, which is pretty much like a firewall, but for containerized workloads. Now, the third challenge that we're facing is really observability. Developers want to know how is their application doing. They wanted to have access to logs produced by the applications. They wanted to know metrics like response time, how much time does it take to process a certain file, and so on. They potentially want to get alerts in case something feels just weird. And of course, if you want, people like chief information security officers, they're unimpressed by just jargon telling them that, yeah, we enabled everything fine, we configured everything secure, trust me. No. We actually need to prove to myself that my security posture is healthy, and also be enabled to prove it to somebody else that, yes, I'm really sticking to my security standards. Now, of course, this is not rocket science. I mean, each cloud provider tends to come with their own solutions to enable this, and they're crazy good. Unfortunately, their own solutions also tends to lock you in to their own cloud provider, which was clearly against the challenges that we were given in this kind of project. So the solution is pretty much compliant Kubernetes. which, if I were to summarize it in 3 lines, it is best of breeds open source solutions with best practice configurations and access to a team of experts that actually knows these solutions and knows how to configure them so as to satisfy a particular security or regulatory requirement. And so our starting point are projects that are being hosted by the Cloud Native Foundation. This is a foundation that is hosting open source, vendor neutral projects that enable you to run in any kind of cloud. So their own definition that I've put in this slide really focus on the fact that just because the word cloud is there doesn't mean that you are not allowed to run your workloads on an on-prem solution. On the contrary, their solution very much enable you to run in a public cloud, in a private cloud, or maybe on both in a hybrid cloud solution, whatever is suitable for your requirement. And the impact that we want to achieve with these cloud native solutions is really allowing the developers to make high impact changes predictably and frequently, and then with minimal toil. So there should be as much possibility for automation. There should be as much opportunity for automation as possible. The Cloud Native Computing Foundation offers a nest for blossoming ecosystem of open source projects on various topics, such as container orchestration, databases, message queues, or storage. There are currently over 900 projects, and the Cloud Native Computing Foundation actively reviews them, either through end-user surveys or by doing its own evaluation of the technical and organizational maturity of projects. And of course, the most prominent and the first Cloud Native Computing Foundation project is Kubernetes. So all this sounds really great. So are we done? Well, no, because while strictly speaking, what I'm just telling you is not rocket science, it's still a lot of work. You need to go ahead and for each of these topics, evaluate what is the most promising project. And this needs to be done at 2 levels. First of all, technically, you really want to make sure that it has the right features for a use case, that it's easy to use, and it has proper documentation so that you don't find this out just when disaster hits you. And then secondly, what I have noticed is very challenging is that it's not only about what each solution supports today, but some of them we found them very feature poor in the past. And then because there was a huge ecosystem and there was a huge enthusiasm built up around them, you suddenly realize that in 1 year, they just skyrocketed feature-wise, and that decisions that used to be suboptimal 1 year ago are suddenly rockstar decisions. So evaluation needs to be also technically, but also respectful to how big is the uptake and how big is the ecosystem around them. Then, of course, once you have chosen these projects, you need to learn about them. First of all, how to set them up, but also how to operate them. You need to really understand what's behind them. You really need to understand, in case they don't work, where should you look at, what are the individual parts, who talks to what, and so on. And then finally, you really need to know how to configure them. And this is, I found, one of the most problematic parts, because minor changes of configuration can have huge impact on your security posture and also on your cloud portability posture. So it might be that you're enabling a certain feature that A, increases your attack surface, and B, it might also make it very difficult to use that particular solution on a different cloud provider. So in order to simplify this work, we have created what we like to call the Swiss Army knife of our team, which is compliant Kubernetes. And basically, we started from looking at various regulations, such as financial regulations, the California Consumer Protection Act, which is around private data, GDPR, patient data law, and HIPAA, a US healthcare regulation. We then looked at various information security standards, mostly ISO 27K. And then we looked at various controls and what kind of projects in the Cloud Native Computing Foundation allows you to deal with these controls in a satisfactory manner. We run this on any cloud out there, whether it's a big US cloud provider or a European cloud, or just bring your own virtual machines or bring your own metal. And then, of course, there is also the very important layer of actually being able to prove to yourself that these components are doing what they are supposed to do, and they're enforcing the controls that you make them enforce. So this is why we're also investing a lot of effort in implementing dashboards to be able to audit the security posture of a compliant Kubernetes cluster. And this is implemented on top of open source projects such as Prometheus and Grafana. So if I were to geek a little bit around and explain you how this looks more technically, we're mostly building everything on top of an open source project called Cubespray, which on one hand has some Terraform providers for infrastructure setup, and on the other hand offers some Ansible roles in order to set up a vanilla Kubernetes layer. And then on top of them, we are using Helm in order to deploy all of the projects that are on top of that. And we pride ourselves with the fact that we're active contributors for Cubespray. So actually we contributed Terraform providers for Exoscale, a large Swiss-Austrian cloud provider, Swiss-Austrian-German cloud provider, UpCloud, which is a Finnish cloud provider, and also VMware, that is a very commonly used solution for on-prem deployments. And we didn't just take Cubespray, but we also have our own wrap around it that configures a few more extra things so as to make sure, for example, that administrative access is restricted and so on. So this all sounds really, really great, but how do you actually run Kubernetes on any cloud? And I'm not sure I will be able to exhaust all the topics, but let me just say that the devil is in the details. So the first thing that we're often encountering and is problematic is sizing. Each cloud provider comes with their different flavors of virtual machines. Some have a different CPU to memory ratio, and it's always difficult to choose the right ones. So then we always have to, okay, depending on what cloud provider is being thrown at us and what is available, we need to choose the proper sizing, the proper size for virtual machines, so as to make sure that compliant Kubernetes runs on top of it. Then the next problem is load balancing. And often what people are used to is a Kubernetes load balancer. However, this has some security implications. For those familiar with administering Kubernetes cluster, this requires you to set in-cluster cloud credentials. So Kubernetes cluster needs to be able to talk back to the cloud provider in order to instantiate load balancers. And we have found in the past that people are not quite understanding this concept quite well, and they often put their own credentials in the Kubernetes cluster, which is not the way you're supposed to do it. You're rather supposed to create specific service, specific credentials just for the Kubernetes cluster and put those inside the cluster if you want to go with this solution. Now, we're also used to deploying Kubernetes on top of platforms that simply do not have any load balancer. And people are very surprised to learn from us that, can you really run Kubernetes in such an environment? Yes, you can. There's absolutely no problem with it. There are some limitations, like, for example, you cannot then enable high availability. So this pretty much compromises, let's say, the availability that you can offer for your data. But, if you don't have any requirement for strong availability, and yeah, why not? It also, service type load balancer won't work if that's something that you require. However, the most common way of getting traffic into the cluster, which is ingresses, will work just fine. And then a solution that maybe makes more sense from a security perspective is just to set up a load balancer at the infrastructure level, either manually or via Terraform. This way you don't have any cloud credentials inside the cluster, and it may increase your security posture depending on what risk profile you are accepting. Now, the same discussion can be had also about storage. You can either use a Kubernetes storage, Kubernetes native storage, or as it's called in the Kubernetes parlance, container storage interface. But again, you need to configure some in-cluster cloud credentials, and you need to be careful with what you use them. Otherwise, if the cloud provider doesn't provide any Kubernetes native storage, no worries. You can also set it up via Rook. This, of course, has a little bit of technical challenge that in that case, you need to set up a custom partitioning table on the virtual machines we're deploying Kubernetes. And you then need knowledge around how to do this properly via Cloud Init in order to not need to do it manually every single time you're setting up a Kubernetes cluster. And of course, in case you just need some smaller, in certain cases, you can also use a local storage. So basically just using the disks of the nodes without any smartness around them. And again, you usually need, in that case, a custom partition table, and there are other implications that you need to be aware of. So these are, let's say, the issues that you should be aware of when you really want to truly use Kubernetes to run your workloads on any cloud. The second thing that we are putting a lot of thought about is how do we actually deal with security? So like I said, Kubernetes does offer a lot of facilities for increasing your Kubernetes, your security posture, but these are not enabled by default. So what we generally offer and put a lot of time into it is, first of all, network segmentation. Clearly, in containerized world, IP addresses, pods are being restarted and destroyed and created quite often. So you cannot have, traditional IP-based firewalling in order to ensure your network segmentation. What we use instead is network policies. For those that are familiar with code, on the right, I'm also displaying how this kind of looks like, which rather instructs a network policy engine. In our case, we use Calico, what pod should talk to what pod, or what namespace should talk to what namespace. And then it's this particular network policy engine that then configures firewall rules accordingly so that your network policies are being enforced. So the example on the right, for example, would show me that I have a network policy called backend, and I want to make sure that it applies to all of the pods that are labeled with the role backend. And I want to make sure that not everybody can talk to them. They can only be accessed from the ingress controller. So it's the component that handles communication from the outside of the internet. And then I only want them to be able to talk to databases pods. And this is a very nice policy to have, because if for some reason an attacker has gained access to my backend containers, then they will very likely try to move laterally, and this will create a lot of suspicious activity. So if I have such a policy, then that will definitely slow them down. Now, of course, we don't only want to slow down attackers, but we also want to detect this particular, that attacks are in progress. And I will show you in the next slide how exactly network policies can also help you with that. Then the second thing that we do with security is we simply minimize the privilege that code has. We used to do this via pod security policies. Now we're looking for different solutions. What this basically allowed you is to not run containers as root, because that opens up some attack vectors against the Linux kernel. And also, we're not allowing privileged containers, which pretty much allows any container to escape the containerization boundary and pretty much take over the whole cluster without any limits. Finally, we also do intrusion detection. We use an open source project called Falco, which basically uses a facility in the kernel called eBPF to monitor the syscalls. And if there's any kind of suspicious activity, like writing files in folders where it's not common to do that, or maybe making some certain network activity that's again suspicious, then Falco will notice that and will inform you about that. And then it's up to you to capture that information and make something useful out of it. So how exactly do you then, actually audit your security posture and make sure that you don't miss out on any of these signals that may show you an impeding attack? So to this end, we have developed also some really nice dashboards. I'm going to demonstrate some of them in our live demo. And basically what they allow you is, for example, if there is any network traffic that got denied, that's a strong indicator. I mean, in the best case, that means that your developers have misconfigured something. In a worst case, it means that you have an attacker in your infrastructure that is trying to move laterally. So you better know about this as quickly as possible, hopefully before they manage to get away with some personal data or something very valuable from you. So this sounds all really nice and great. It must cost a ton to have this kind of solution, right? Well, actually, no. Compliant Kubernetes is open source. We try to make sure that we only use off-the-shelf open source solution. We also try to make sure that the projects are as vendor neutral as possible. As you might know, there is quite a bit of controversy, in the open source ecosystem right now, with a few projects having changed their license to, let's say, uncertain legal terms. And by aiming for vendor neutral projects, you're also hedging yourself against this particular licensing change risk. And in fact, you're free to download and operate Compliant Kubernetes yourself. And we offer this for free because we believe that where the real value lies in, where we're really good at and where we really deliver value, is in the knowledge that is required to translate regulatory and security requirements into configurations of Compliant Kubernetes. So let me now zoom in on what exactly do we build in the Glasswall case. So we're pretty much asked for two kinds of deployments, a pet-like configuration and a kettle-like configuration. So pet and kettle, for those unfamiliar with this, is a little bit of a metaphor on how you're treating your servers or your infrastructure or your software environments. Pet is something that you care for, and if it gets sick, you you bring it to the doctor and you try to make it live as much as possible. Whereas the cattle pretty much, you don't even name them, you just give them a number. In case one of them gets sick, you just slaughter them and replace it with the next cattle. And we had both of these deployments available. So we had the pet-like production deployment, which was aiming for high availability and ease of operations and upgrades. In this case, it made a lot more sense to have a cloud provider integration and to use load balancer and storage from the underlying cloud provider in order to make sure that you are piggybacking on the information security and information availability features of the underlying cloud provider. And this would be set up and upgraded pretty much layer by layer, as I showed up and as I showed in the previous diagram. And then we also had more like a cattle-like deployment. This was very useful for development and for demos. And in this case, it was more effective to just not have any cloud provider integration, to just use local storage. And then we basically ended up packaging everything as a single Amazon machine image or as a single virtual vSphere VMDK virtual machine disk image. And this was done using Packer. And the final result is pretty much like a one-click launch of the whole solution, including the Glasswall application on top of it via CloudFormation. And we did that, like I said, both on VMware and on the AWS. And due to certain limitations in the Amazon Kubernetes service, we chose directly on Amazon virtual machines and not on the managed Kubernetes solution. So let me just give you a little bit of an intuition of how the cattle-like deployment looks like. So we're really distinguishing between two phases here, between build time and launch time. So at build time, we have a public GitHub repository, which every time you're making a change, a GitHub action is being triggered. And that pretty much sets up, generates a new Amazon machine image or a virtual machine disk image. And again, inside that GitHub action, it's layer by layer. First, the Cubespray layer. So we're starting directly from Ansible since Packer is dealing with infrastructure setup. So we're spraying over vanilla Kubernetes cluster using Cubespray and Ansible. We're spraying over our applications via Helm and Helm file. And then in the end, all of these get packaged into a single Amazon machine image. So what we're aiming for here is a single node Kubernetes cluster in order to make it as easy as possible to deploy for developers. And then once this is deployed, an Amazon machine image is being stored in Glasswall's AWS account. And from where, if you're having the proper access and the proper credential, basically you just go on the GitHub project and click on Launch Stack. You're going to be asked about a few parameters, which you don't need to care about because we have good defaults in place. But if you do care about these parameters, such as you want to use a new container image for the ICAP adaptation service, or you want to use a new image for something else, you can, of course, do that. And then, the CloudFormation template will be launched accordingly. So let me show you approximately what you would obtain, what you do if you do all of this. So first of all, I assume that you see all my window, otherwise please complain. So first of all, we have all our documentation publicly available on compliantkubernetes.io, where not only that we are teaching you a little bit about how we see regulatory compliance and how we see Cloud Native Computing Foundation projects give answers to complete compliance issues, but you're also allowed to, encouraged to click on some of these controls. For example, when it comes to network security, how exactly do I ensure that there is a proper network security? How do I make communication segregation work inside the Kubernetes cluster? And then just click on it. And then I have a description of relevant regulations, mapping to ISO 27000 controls, and a dashboard that allows me to actually audit my posture. And we're also making recommendations on if something weird happens, then how do you handle non-compliance? Because this is also an issue. Like, okay, so since there are developers and since there are operators and since there are so many roles that interact with compliant Kubernetes, who do I really complain to if something like this is happening? So the end result is, let me show you how this looks like in our demo environment. Like I said, we build on our dashboards on top of Grafana. And here we have here you can already notice our best practice configuration. we don't just allow you to use admin here as a password, but rather we require you in most common configurations to log in via your identity provider, because this significantly facilitates access control within your organization. And also it enables easier onboarding and offboarding of, say, your on-call team or your DevOps team and so on. In my particular case, in my demo environment, I'm using Google as my identity provider. So I'm going to log into that. And I have been successfully recognized as being myself. For those of you who are familiar with Grafana, you might even notice that I can't actually change these dashboards because I only have read-only Grafana access. I can only see them. And this is pretty intended, right? A CISO should not be worried about how to set up Grafana dashboard. He should just be demanding on what Grafana dashboards are there and should regularly check them. So for example, if I look at my network policy dashboard, I can see here the packets that are the number of packets per second that were allowed by network policy to go from a pod, that were allowed to go to a pod, and also the number of packets that were not allowed, that were dropped to go from a pod and to a pod. And I can actually see here the name of the pod that generated this kind of events as time has passed through. So this is great because it allows me, for example, to say like, oh, this didn't really happen in the last week. Why is this suddenly happening today, now? And then if I see suddenly that, oh, there is traffic that is dropped, that, like I said, in the best case, it just means a misconfiguration. In a worst case, it means that there is an attacker that tries to move laterally. Similarly, when you're looking at packets allowed, this is something that is usually not, say, as burning as packets denied, but still a huge increase in packets allowed traffic can also be considered as a question mark. Is it that there are some components in your system that are just too chatty? Is it that maybe somebody's using you for an amplification attack, which are very common nowadays? So you're just sending one byte to an unsuspecting victim, and that one sends maybe hundreds of bytes in return to somebody else, and that can be used, for very sophisticated denial of service attacks. So by looking at the packets allowed and seeing if it increases unexpectedly, you can proactively prevent being a trampoline for amplification attacks, and instead, proactively deal with this situation. Similarly, we have Intrusion Action dashboard. Like I said, we're using Falco for that. And this one, for example, shows me various events depending on what happened. And here, for example, I see a few events that are a little bit weird. So for example, one of my containers has tried to contact the Kubernetes API server. This might be suspicious activity. It might just be that this is how my application is supposed to operate. Anyway, it's something that is worth investigating. And Falco provides for very many of these kind of alerts, like writing to suspicious file path that it should really not, or trying to do an inbound SSH or an outbound SSH connection, things that are really scary and are really, not supposed to happen in a production Kubernetes cluster. And of course, Falco can block them, but you want to know even if this kind of activity was blocked. And finally, we also have some dashboards for capacity management. So Kubernetes is coming in with self-healing facilities, which are great because it means that you don't have to wake up your operations team at 2 a.m. because a server went down. But this also has the problem that it may potentially hide failures, and you would only notice them when it's too late. When, for example, the second server has failed, and you're just assuming that up to that point, all of the servers were up. So this is why we're also having a capacity management dashboard that signals you all of the red flags when it comes to capacity management, like pods that are not ready, or pods that are failing, or deployments with unavailable pod. It also shows you like, okay, I need to have 100% of my nodes ready. So nodes are the servers on which my pods are running. Do I actually have them ready, or is it just me thinking that they're ready? And finally, for example, often it's overlooked when running a Kubernetes cluster is for developers to set CPU requests and memory requests on their pods. And if you don't do this, that means that Kubernetes is doing a really bad job when it comes to capacity management. And again, you might have these indicate issues that are better caught before they become a problem, and you're starting to fill up your servers with things that don't work anymore. So please check it out, compliantkubernetes.io. and let us know what you think about it and how it can solve your particular regulatory or security needs. And I'm happy to take up questions now. Thank you for your attention.
Hi, Cristian, it's Sarah here. Just really quick, just thank you for that. I'm a relatively new convert to this space, and you've helped me navigate some of the specifics for this, although the traditions of security apply equally in lots of ways. So it was a good presentation. I think.
Thank you.
Mapping to a report on what our compliance status is as a whole, just being clear about the portion of our risk that this is contributing or fixing is really powerful. So that piece was probably where I was most interested.
Thank you.
So, Cristian, one question from my side, right? One of the things that we talked about, right, was this idea, right, of running more clusters and less nodes in total, i.e., instead of smaller clusters with large nodes, having a bigger number of clusters with 1 or 2, 3, 4 nodes each, but kind of that's it. Where even your entire container, right, so your entire cluster becomes more like a pet, right? So sorry, a cattle, right? In that case. Any other views? And I know you mentioned that in the presentation, but any other thoughts on that?
So to me, these are really two different modes of running Kubernetes, right? You're either having a big virtual machine in which you're cramming also the master node and all of the applications, which I think is really good for development work and for demos and things like that. But you're also risking availability, right? Because if that single virtual machine or that single server on which this whole installation is running goes down, then pretty much everything goes down. In contrast, what we are often used to is pretty much setting up a lot of redundancy. So it has generally 3 times master node replication and 3 times worker node replication. We separate the master node and worker nodes because for performance concerns, right? You don't want, for example, an application that is suddenly misbehaving in a worker node to also affect your master nodes to the point where you cannot even kill it properly. And similarly, if one of your master nodes goes down, since you have triple replication and Kubernetes requires a quorum to function properly, it can work just fine with 2 masters, assuming you quickly bring back the third master. So to me, it's really, what do you want to do? Do you just want something that is quick to spin up and then you use it, and then maybe a few days or a few weeks later you just kill it, which is the kettle approach? Or do you actually want to make a 24/7 service that is up and that you do upgrades in place? I think this is a really huge difference for me, that in many configurations, you actually want to upgrade from Kubernetes 119.3 to 119.4 without any downtime, any noticeable downtime on the application on top. And when I mean any noticeable downtime, I really mean that we're dealing often with stateful applications, so databases. We're dealing with applications which might not be able to tolerate a lack of capacity temporarily, because that trickles down to the user experience. So we really, in production at least, we're used to setting these up in a way that you can in place upgrade them. And that's fine. But like I said, I see that there's value in both of these configurations, and whatever challenge you throw at us, we can just handle it. That's really the message I want to highlight here. Did I answer your question? No, Dennis, I can't hear you.
Dennis, you're still muted.
Oh, sorry. Yeah, I would say that it also, I think, depends a lot on the application, right? Because I have to say that I quite like the idea of using the cluster as almost the thing that is the cattle, right? And then it's about, for example, in your worker nodes here, I think we talked about this, right? So your worker nodes, I almost view them as worker clusters, almost, right? That's almost like in fact, in our case, it was, right? Because those worker nodes would actually, in some cases, can be running completely, a complete Kubernetes stack, right? So you use that almost less as a node, but more as a cluster that you then manage through this.
Yeah, so in your case, in the kettle-like approach, we basically put all of these master nodes and all of these worker nodes in a single big node. And like I said, you're then losing availability, right? Because if that single large node becomes a single point of failure. For your
Well, no, because we run multiple of those, right?
Say again?
We run multiple of those, right? So
yeah, so for your application that works, right? To run multiple Kubernetes cluster with a load balance in front of them. But often many of our customers, they would just get very confused if say we have a customer that runs a healthcare application, and then suddenly they need to connect to a different Kubernetes cluster to get the same, it would be just very confusing for them. So it depends a bit also on what is your demarcation line. But what often people ask us as demarcation, really give us access to the Kubernetes API. We run our applications via Helm, via deployments, via whatnot, and just try to make sure that the platform underneath is as stable as possible.
Yep. No, it's a great model.
Yeah, so I just wanted to highlight that it's really not like one is better and the other one is worse. It's just what are your requirements in terms of security and availability, and then we can decide which one is more appropriate for you, for your use case.
Yeah, absolutely. Cool. All right. Yeah. Not sure we have more questions.
There's no questions in the chat.
Okay. I think it's great then. Then you can, I think the recording is available, and I think it's worth maybe doing a session in a couple of months from now where we could also show the evolution of this, right? Because we're going to keep deploying stuff on top of it. So
yeah,
it'd be good.
It would be cool to see your journey.
Yeah. Good stuff. All right. I think, Kate, you can stop the recording.